Okay, hello everyone. I'm here to tell you about the query rewrite plugin interfaces. And actually, there are several interfaces, as most of you probably already know. My name is Martin Hassan. I'm an optimizer developer at Oracle. You can reach me at this email address. Here's my agenda for today. First, before I start, I'd like to take a little survey here. First of all, how many of you were looking at Sveta's presentation? Not that many at all. How many paid attention? Okay, that's good. Because you guys will notice that this presentation is pretty much covering almost the exact same thing that she was covering. But she did the advanced stuff, and I explained the simple stuff. So if she explained calculus, I'm going to explain multiplication to you. So it's a little out of order. But first I'd like to ask you, has anybody of you used plugins? I mean, installing plugins, uninstalled plugins on SQL? Have you written plugins? Cool. Have you used query rewrite plugins? Still some hands. And have you written any query rewrite plugins? That's one hand. Yeah. First, I'll tell you about the philosophy behind the query rewrites APIs. It's when we started out, we thought, how do we do this with query rewrites? We want it to be as simple as possible to the user, because inside the server there are so many rewrites going on anyway. We have, for example, password obfuscation, and then you have to keep track of the rewritten version of the query goes to that log, and the original query goes to that log, and it all depends on the SQL mode and everything. So we wanted to keep pretty simple, like once a query is rewritten, you throw away the old one, the rewritten queries, the query. So it should be something like this. Somebody sitting in the middle, rewriting your query, capturing it on the way to the server, and the client gets notified that, hey, I rewrote your query, and now it's something else, but the server doesn't really see what the original query was in the first place. So we actually talked about implementing it this way, more or less like some kind of proxy sitting in between the server, possibly on a different machine. But then we realized that would be kind of too complex, so then we decided to do it inside the server. Because if you do it inside the server, you can also rewrite the query after you've parsed it. So that's why we have two APIs. We have the pre-parse and the post-parse API. The benefit of the pre-parse API is, of course, the low overhead. The downside is that you don't have any structure. So it just takes a string and returns a string. So the post-parse API operates on parse tree instead, and that's good because you know the structure of the query, and you can find the strings inside it. So you won't get, if you're searching for a certain string constantly, you will not find it inside a comment, because comments are washed away by the time you parsed, which is very good. And the downside is that you can't edit the parse tree destructively, so you have to build a new string and then re-parse that string. And you also need to traverse the parse tree, which can potentially be performance bottleneck, because you have to remember that these rewrites are run on every query, and that can slow down the system terribly. So, and with that, I'll tell you a bit about the APIs that we have. Here's a schematic of it, the query API. First, the query comes in from something I call the network, whatever that is. What I mean is where the queries come in one by one to be parsed from some kind of client. So the pre-parse API captures the query at that stage and calls out to the plugins. And the post-parse API works on parse tree, which is commonly known as a list structure. So it calls out to the plugins, gets the query back, and plugs it back in. So also I'd like to take a moment and show you what they actually look like in practice. Here I'm using the example plugin, which is, comes with a MySQL distribution. So if you're compiling from source, you need to set the plugin your flag, point to where your plugin is located. And this one just rewrites queries to lowercase. So it's only for registration. And so here I run a query. As you can see, every character in the query is rewritten to lowercase. It doesn't care if it's constant or not. There's also kind of strange thing here. You notice that you get 2 notes that the query is rewritten, because what happens is that the show warnings command itself is being rewritten, and that happens before parsing. So this error is queued up before parsing. That means by the time you execute the show command, you get actually 2 warnings, which is a bit confusing. The APIs are tiered. So you have the server at the bottom, and as Sveta said, you had the Audit API, and the Query Rewrite API builds on top of the Audit API, and then we have the specific rewrite APIs on top of that. So the general API is where this note is produced that says that your query was rewritten. And the pre-parse and post-parse API, these APIs are the ones that call out to the plugins. And now I'll explain to you what Sveta didn't have time to explain, why this is so interconnected with the Audit API. Here is the definition of auditing from Wikipedia. So what the Audit API does, it lets you use pluggable auditing, and it's essentially a type of logging that you use to detect illegal activities in the database afterwards. There are certain laws that depends on this, certain regulations. Some also require that you log who sees certain data. Some require logging of modification of data. That could be anti-corruption laws or business laws or personal privacy laws. So that's what this is used for. But it also provides a very handy infrastructure for locking the plugins. It's important to lock an audit plugin so that you can't uninstall it while you are auditing, while you're writing to the audit log. In order to make that scale to thousands of parse events per second, we need to do some clever caching here. And the Audit API is really efficient at that. It actually gathers audit plugins based on the event that they are listening to. So certain audit plugins will listen to login events, some will listen to query events, some will listen to DDL events. So this way we can have them all queued up, and once an event comes, we already have a queue of all the plugins. We can just call them straight away. That does wonders for performance. So we discovered after a while that query rewrite fit in really nicely into this. We just make another event out of the parsing, and then we can get all this infrastructure for free. And the Audit API also provides parameter parsing to the plugins. It's based on void pointers and bitmaps, so it's a little crude, but that way you know that it works on all platforms. And with that, I'll go into explaining how you declare plugins. Does it look familiar? I guess to those who saw Sveta's presentation, this is exactly the same. The convention for this is a specific plugin descriptor, which describes how you will handle the actual rewrite event. So the convention here is that you use the version of the plugin type, and this, in this case it's audit, so it's MySQL audit interface version. You can use the release THD function, which is used when the plugin is dissociated from the session context. This typically, in practice, this typically happens when you close a session. You have the event notify function, which will handle an event, and you subscribe to events by using class masks. I really don't have to say that much because it's already been covered. So I can skip this, and the next slide is pretty much the same. This is good. So this might just leave room for questions in the end. So I'll skip to how to write the plugins. My example that I'm using is the plugin that rewrites query to lowercase. So in my experience, you always want to include my global.h. I don't know if Sweta managed to get by without doing it, but in my experience, you'll run into all sorts of trouble if you don't. And then you spend several hours searching for strange bugs, and then you ask some guru and he tells you, well, you need to include my global.h first. So my advice is you do that. Then you can delete it later if you don't need to. You have the plugin init function where you can set up your plugin, allocate memory as you need. If you don't return 0, the install plugin command will fail. And that's the rewrite function. It hasn't changed since last time. And here you can look at the event class, and it can be either pre-parse or post-parse. So this is just for this example that we have a plugin that actually handles both pre- and post-parse plugins. In practice, you probably will not want to write a plugin that rewrites both before and after parsing. But I thought it was a good example. Moving on, return 0 for success. So now I'd like to get into this piece here, where we do the pre-parse rewrite. So this is simplistic. We allocate a new string, same length as the old one. Room for a new character. We just loop through it, copy everything, and change it to lower. We point the event to the rewritten query, and we set the length. And we have to set this flag as well, or else the rewritten queries just gets ignored, thrown away. If you look carefully here, you can see that I use my malloc, which is the Alloc Service, which I'll tell you about in a few slides. It's using a performance schema key. So keep that in mind for a few slides. Now I'll tell you a bit about the plugin services. This is something I thought I wouldn't have time to tell you about, but oh yeah, that's good. I can make a slow stop to this one. I think I will. I originally planned to tell you about how to write post-parse plugin, but I think I will ignore that unless you don't have any questions. In that case, I might do it. So what is a plugin service? Plugins can publish very much on their own without some help from the server, especially post-parse plugins, because they only have an opaque pointer to the THD object, and opaque is just a fancy word for a void pointer, so it can't do anything with it. So in plugin services, the flow goes like this. The Audit API calls out to the plugins, plugins do some execution, and while they're doing that, they might call up some functionality from the server. And functionality from the server offered to plugins is what we call service. And ideally, a plugin should not use any other functionality from the server unless it's defined as a service. So a plugin that includes header files that are internal to the server is what's usually called a dirty plugin, because you're relying on code that you don't know if it will stay that way, and you don't have any version control over it. So it might work in one version, it might crash and burn in the next. So don't do that. First of all, we have the Parser Service. It lets you parse a string. You want to do this in a post-parse query rewrite after your post-parse is complete. Of course, if you write a post-parse plugin, you already have the parse reset by the time you called, so you don't need to do it there then. You can get a normalized query, which is a kind of anonymized query where all the literals in the query are anonymized, and you have query digest, which is an MD5 of that. There's only one post-parse query reader plugin I know of, and it's the one I wrote, the one that we released. But what it does, it uses these normalized queries and the query digests, so it can pattern match with queries that you rewrite, and it can do lookup in a hash table to see, like, okay, this pattern of a query gets rewritten to that. And that we really got really good performance with that. We got a few percent overhead, which is acceptable under the circumstances. So I can't cover the rewriter plugin in this short time. It would require a session on itself. And also covering the Parser Service exhaustively would be a session itself as well. So I'll just show you a little bit what the code looks like here. This is from service parser.h. So what you can do is you can parse a string. You can get the normalized query. You can get a digest, and what you can do is traverse a tree using a callback function, just a C function pointer to a visitor function. And of course, for an item or a literal in the query, you can print it. So that's really all I have time to say about the Parser Service right now. We also have the Alloc Service, and it lets you allocate memory. That's all it does, and it's really good at that. So I guess some of you wonder, why would you want to use the server to allocate memory? Why can't you just use malloc and free yourself? There's several good reasons. One reason is that you can use the performance schema implementation, as I told you to keep in mind a few slides back. And that way it's very good, because you can get the timing and the mutex weights together with all the other mutex weights in the server inside performance schema, which is very handy. And the server will also clean up the memory automatically for you. So I guess my time's up. Yeah. So I guess I have time for one question or two short ones.
What other plugins one can think of, like post-parse?
I'm sorry?
What other post plugins can you think of? What other possibilities?
Actually, it's a kind of limited API, because it was we only had one use case for the API, so we implemented exactly what that API uses. What you could do is you could loop through the query, and you can find the literals in the query. And if you're a little more hackish than I I am allowed to recommend it to be, you can go in and actually change the strings. So you can actually switch around literals, like switch places, for example. If you have select 1,2, you can turn that around to select 2,1, for instance. Yeah? No, you can't, because you have to successfully parse it in order to do a post-parse rewrite. So that's the problem. Huh? Do I have time for one more?
How does explain behaves with the rewriting?
That's where you have to go back to the philosophy with the monkey picture, where it's like, imagine that somebody rewrote the query before it came to the server. So it should look like somebody took the query and the old server saw was a new query and the old one is gone. So yeah, that was really one of those tricky cases where we really had to decide how we want the philosophy to be. I guess my time's up.
Yes.
Thank you.